let's look at the social science example on forgetting. In a psychological experiment, students were shown a set of nonsense syllables such as POK, poke, ritz, or dick, DQ, and so on, and asked to recall them every minute thereafter. The percentage of R of t who retained the syllable after t minutes was found to be given by the logarithmic learning model. R of t equals 80 minus 27 times natural log of t for t in between 1 and 15 minutes, right? Okay, so I can see this graph is going down. So see what that, all right, this is cute. See, when they first ask these students 1 minute after showing these random syllables, only 80% of them retained the syllables. Like the 20% already forgot it all. Right? Hey, but that's going down, right? So after 10 minute-ish, only about 20-ish% of students are still retaining these syllables, but I see that's going down. 14 of them are still remembering. 14, I'm sorry, close to 10% of students are still remembering it after 14 minutes. But it makes sense that the graph is going down because of percentage of students retaining the syllable is probably going down as they forget it as time goes, okay? And it's going from 1 minute to 15 minutes. So I guess they will stop after 15 minutes. They will not be asking anymore. So what are we looking for in part A? What percentage of students retain the syllable after 1 minute? I think it's just 80%, right? Because reading the graph, 1 minute is up at 80%. So my answer is 80%, but let's use the function to figure that out. Plug in 1 into R of t, right there, okay? So if you do 80 minus 27 times natural log of 1. See, natural log of 1, this will give you 0 right here, right? So that's just 0. So you end up with 80 minus 27 times 0. Well, you can definitely type this into your calculator and do it. But natural log of 1 is 0. So if you do 80 minus 0, you will get 80. So the answer is 80% of students still remembering these random syllables. All right, now they want us to find R prime of t, and now that's how this percentage is changing. So in order to do that, we need to first find that derivative function. So let me copy this down there and find the derivative of this R function, okay? All right, so if you find R prime of t, what is the derivative of 80? Well, that's just 0, isn't it? Now, let's go find the derivative of the second term. Okay, so you write down minus 27. But what is the derivative of natural log of t? What is the derivative of natural log of t? Well, that is 1 over t. So if I try to simplify this little messy looking expression, R prime of t is just negative 27 over t. So let's plug in that number they want us to evaluate. They want us to evaluate R prime of 2. So let's plug in 2 in there. R prime of 2 is negative 27 divided by 2, and that is negative 13.5 words per minute. Actually, not words, I'm sorry. Percentage points. It's going down that many percentage points, right? Not percentage, percentage points per minute. So I think we have this fill in the blank for interpretation. So let's go ahead and fill this out. This result indicates that indicates the blink minute after. Okay, 2 minutes after, because that's the number we plugged in, right? After students have been shown the syllable, the percentage of them who retain the syllable is decreasing, because it's negative number, right? It's decreasing at the rate of 13.5% per minute. Okay, so that's the interpretation of R prime of t, R prime of 2. All right, last one. When will the percentage of students who retain the syllable drop to 20%? So we're not looking at how fast they are forgetting. Okay, we're not looking at like how fast this percentage is going down. We're just looking at when will this percentage be equal to 20. So I'm gonna go ahead and just set this percentage equation equal to 20%. Okay, so here's my plan. So 20 equals 80 minus 27 times natural log of t. I will start this by subtracting 80 from both sides. That will give me negative 60 equals negative 27 natural log of t. I'll do the work over here. My next step is to divide both sides by negative 27, right? So if I divide negative by negative, the left-hand side will be, what, 60 over 27. I guess we can reduce that fraction, but I'll write that just like that for a second. And then the right side is just natural log of t. To solve this for t, you need to rewrite this in exponential form. Now, exponential form for a natural log, the base is going to be e. The exponent is going to be 60 over 27, and this equals t. So let's figure out how many minutes this is, okay? So I need a calculator for this. I'll open up Desmos Scientific and type in, what was I typing in? E raised to the 60 divided by 27. And that is approximately 9.23 minutes. So after about 9 minutes, you show them the syllable. Only 20% of these students will remember what they saw 9 minutes ago. So let's see if this looks right on the graph real quick. So 9.23 minutes. So on the graph, so here is 9 minutes, right? So like about like right there. If I go straight up, there's the graph, right? I'm going to try to read if this is about 20% on the y-axis. Yeah, I believe it. Yeah, looks about 20%. So yes, the answer is 9.23%. Okay. See guys, whenever I write these derivative function like R prime of 2, I thought I will be using that for the last part, but we really didn't. We just used the original equation, set it equal to 20, and solve that log equation. But this was an example on page 93.